Hello, I am Dr. Rishi Paliwal on behalf of Dr. Shivani Rai Paliwal with another interesting and learning episode of B.Pharma on the important unit of paper and paper boards, which is very important unit of the section of packaging technology. B.Pharm 7th semester. Let's start our episode while taking a look at what we are going to learn today. Module 1 Introduction, Module 2 Types of paper, Module 3 Quality control testing of papers and paper boards, Module 4 Folding cartoons, and Module 5 Conclusions. Module 1 Introduction. Let's start with general introduction about packaging technology and a brief discussion of paper and board-based packaging materials and their use in pharmaceutical packaging. Packaging is the science, art, and technology of enclosing or protecting products for distribution, storage, sale, and use. Packaging also refers to the process of design, evaluation, and production of packages. Packaging can be described as a coordinated system of preparing goods for transport, warehousing, logistics, sale, and end use. Objectives of packaging: physical protection, barrier protection, contaminant or agglomeration, security, convenience. Packaging types. Primary packaging is the material that first envelopes the product and holds it. This usually is the smallest unit of distribution or use and is the package which is in direct contact with the contents. Secondary packaging is outside the primary packaging, perhaps used to group primary packages together. Tertiary packaging is used for bulk handling, warehouse storage, and transport shipping. The most common form is a palletized unit load that packs tightly into containers. Table 1. Type of packaging. In Table 1, we divided into two parts: primary packaging and secondary packaging. Primary packaging includes ampoules, vials, containers, dosing dropper closures, plastic as well as metal, syringes, strip package, and blister packaging. In secondary packaging, paper and boards, cartoons, corrugated fibers. Papers and paper boards. Pharmaceutical products generally require a standard of packaging which is superior to that of most other products in order to support and comply with their main requirements, that is proven efficacy, safety, uniformity, reproducibility, integrity, purity with limited impurities, minimum side effect coupled to minimum product liability risk, and a good shelf-life stability profile. The materials widely used in packaging are paper, glass, plastic, and rubber. The history of paper making in particular is long, and the earliest recorded British mention is in the 13th century. It has always used forms of cellulose fiber but began to use wood pulp in the mid-19th century, which has continued gradually to replace the older material, so that majority of the papers and boards made today are from the wood pulp root. Papers and boards are used in the following pharmaceutical packaging applications: labels and leaflets, wrapping materials, bags and sacks, collapsible and rigid cartons and boxes, shipping and transit outers, both corrugated and solid, gummed tape, fitment for cases, composite tubes and drums, molded pulp board containers, paper liners, linings, and laminations. The basis of all paper and board is pulp, which is in fact refined cellulose, with the formula C6H10O5N, where N is between 800 and 1500. The crude extracted cellulose is made up of three parts as follows. Number 1, hollow cellulose. This is 70 to 80% of the wood. It is the whole water insoluble carbohydrate fraction comprising. Alpha cellulose, which is insoluble in strong caustic soda, hemicellulose, which is soluble in dilute caustic soda, beta cellulose, which is reprecipitated by dilute acid, gamma cellulose, which is the remainder of the cellulose fraction. There is in fact no single compound holocellulose, since the structure and crystallinity of the cellulose fibers vary with the source of the board. This is part of the reason for the variation in properties of pulps. Number 2 is lignin. This varies between 17% and 30% of the bulk and is an amorphous phenyl propane polymer which is found intimately associated with the holocellulose. It is not a fibrous material and therefore is of no value in the pulping process. Number 3 is the extractives, which forms between 3% and 8% of the bulk and are mainly other carbohydrates, soluble mineral salts, resins, fats and tannins, which may be washed out with water. The individual fiber of cellulose are very strong and of varying length, that is spartograss 1.5 mm, coniferous wood 3.5 mm and broadleaf wood 1.2 mm. And those that are preferentially used for paper and boards are between about 1 and 4 mm in length. Then manufacturing process. To manufacture paper or board, there are two basic processes. A. Pulping, then B. Machine conversion into paper or board. Let us discuss the pulping first. Pulping. The treatment of the fiber, pulp, is the major influence on the properties and cost of the paper or board produced. The objective in pulping is to tease out undamaged fibers from the mass of the wood, so that these fibers can be reworked into the smooth paper board required. There are three major processes which reduce raw material, that is, any of the cellulose containing material mentioned above to pulp. Number 1, mechanical pulping. Number 2, chemical pulping. Number 3, semi-chemical or combination pulping. Machine conversion into paper, Fourdrinier system. This is the most popular system still used today, even though the basic system was invented in the earlier 19th century. Pulp, including all the additives needed for a particular paper, in suspension is pumped into the stuff chest, then let down. The machine starts at the wet end, parts 1 to 4, and finishes at the dry end, parts 5 to 9. Thus, number 1, a stuff chest. Number 2, a breast box or head box. Number 3, a slice. Number 4, Fourdrinier wire with vacuum boxes. Number 5, presses. 6, dryers. Number 7, machine glazed dryer. Number 8, calendar stacks. And number 9, reeling. Figure 1. Machine conversion into paper, Fourdrinier system. Paper used in the pharmaceutical industry vary from about 40 gram per meter square substance up to about 175 gram meter square. Machine conversion into board. In many ways, this is very similar to the making of paper, except that the multiply production systems are more suitable than the basic single wire Fourdrinier system. Board covers rigid and folding box boards, solid and corrugated fiber board, fiber drums and components of the composite containers. One of the different type of machine used at present for making board is the bat or cylinder machine. Module 2. Types of papers used in pharmaceutical industry. The more common type of paper used in the pharmaceutical packaging are as follows. Kraft paper. Kraft paper used as an outer facing for corrugated boards, solid boards, spirally bound case and fiber board drums. Uncoated papers. Uncoated papers usually from high grade chemical pulp source used in thin caliper for small labels and leaflets. One side coated and MG papers are used for the heavier weighted labeling material. Two side coated lightweight papers are used for leaflets. Glassine paper is super-calendared grease-proof paper. Grease-proof paper relies on the closing up of the pores between the fibers achieved by wetting the fibers for a very long time. Whiteboard-free paper. Whiteboard-free paper for laminate is usually one-side coated paper that has been super-calendared to make the outside coated surface less permeable. Test liners. So-called test liners in two grades are made entirely from recycled material used for internal liners in corrugated boards production and as both liners for corrugated fitments. Vegetable parchment paper. Vegetable parchment paper is made by a process of treating the absorbent paper with sulfuric acid, which enhances the bed strength of the paper. This is the most water resistant paper of all. It is usually used for dressing packs. It has good resistance to fats and greases. Dear students, till now we have seen various paper packaging materials and types of papers used in pharmaceutical packaging. Now we will discuss about quality control testing of paper packaging material. Module 3. Quality control testing. It is fundamental to a good understanding of paper and board that the testing regimes that can be used and the specific test and the reason for using those tests are appreciated. The reason for testing is to gain information, thereby ascertaining the acceptability of the test piece in comparison with a specification. That specification should be drawn up so that if all results passes, the material is fit for the purpose that is intended to fulfill. All tests must be relevant to the use of the material and must be understood by all the parties involved. This need has led to a series of standard tests, British, BSI, ASTM, etc. Testing conditions have also to be defined as paper and boards are very susceptible to humidity and temperature changes. It is therefore essential that the test pieces for paper and boards are in fact conditioned so that the test can be carried out under standard conditions, thereby giving fair comparisons. Those conditions usually quoted are temperature 23 degrees Celsius plus minus 1 degree Celsius as per BS 3431 and ISO 187. Relative humidity 50% plus minus 2%, BS 3431 and ISO 187. The reporting of results should include at least the following data. Number 1. The test method used, that is grammage BS 3432-1980. Always specify the date of the method as the BS and all the other standards are routinely updated. Number 2. The instrument used, its reference number. Number 3. The test conditions. Number 4. The size of the test pieces where relevant. Number 5. The number of replicate tests per sample. Number 6. The unit used, that is very important as a number of different units are used in reporting. Both the SI and imperial system are in use together. Number 7. Any other fact relevant to the test piece, that is discoloration of a white test piece on moisture containing testing. General test for paper and board. Number 1. Sample condition of paper and board. Number 2. Pre-test procedure for paper and board. Number 3. Moisture content. Number 4. Folding endurance using various instruments that fold the test piece back and forth through a specified angle until rupture occurs. Applies to all forms of paper and boards, but there may be different instruments for different boards. Number 5. Density of paper and board. These are methods of test for rigid cellular materials. There are 14 different test methods for aspect of the physical properties, dimensions, apparent density, compression strength, dimension stability, cross-breaking strength, shear modulus, thermal conditions, water vapor transmission, tensile strength, friability, and coefficient of linear thermal expansion. Number 6. Method for determining air permeability. Permeability is the mean airflow through unit area under unit pressure differences in unit time under specified conditions expressed in minute Pascal inverse second inverse. Grammage or substance. The weight of material per unit area of the sample usually confined to papers and boards, excluding the manufactured corrugated sheet but including the component parts of the corrugated sheet. Units are usually gram per meter square. Number 8. Paper caliper. Paper caliper represents single sheet thickness between one surface and the other. Measure over a specified area and under a specific static load by means of a high precision dead weight micrometer. Number 9. Tensile strength. Both wet and dry. The maximum tensile force per unit width that a paper or board will withstand before breaking. The stretch at break is the measured elongation at the moment of rupture of a test piece when tested under specific conditions. Number 10. Tear strength either across or along the grain. The mean force required to continue the tearing of an initial cut in a single sheet of paper and four torn together through a fixed distance using a pendulum to apply the tearing force. The work done in tearing the test piece is measured by the loss of potential energy of the pendulum. Number 11. Worst strength, both wet and dry. The maximum uniformity distributed pressure applied at right angles to the surface which a test piece of paper and board will stand under the conditions of the test. The test piece is placed into contact with a circular diaphragm, the test piece being clamped around the periphery but free in the center of bulge with the diaphragm. Hydraulic pressure is applied to the diaphragm, bulging it until the test piece bursts. This denotes the general strength of the test piece. Number 12 is the puncture resistance. A triangular pyramid puncture head is attached to a pendulum. It is released to swing onto a test piece. The energy required to force the puncture head right through the piece, that is, to make the initial puncture and to tear and bend open the test piece, is measured. Number 13. Stiffness of thick papers and boards. This is the degree of resistance offered by a paper or board when it is bent under specified conditions. Number 14. Ply bonds of boards. This test ensures that the various plies of a multiply board have bonded together enough to ensure that they will perform satisfactorily in service. This test applies not to boards that use an adhesive as the bonding agent, that is pasteboard, but to those in which the plies are joined by heat and pressure only. Number 15. Creasability of boards. The method to determine the creasing quality of carton board within the range of 300 to 1000 meter. This is important to the packaging line since if the creases are not correct and do not assist the carton erection, the cartooning machine will not function correctly. Number 16 is the Cobb test for water absorbency. This measures the mass of water absorbed by 1 meter square of the test piece in a specified time under a head of 1 centimeter of water. It is determined by weighing before and after exposure to the water and usually quoted in gram per meter square. Number 17. Rub resistance. This is the resistance of a printed test piece to withstand rubbing against either another similar printed test piece or against a plain test specimen. The objective is to see that the ink per print has curved and will not scrub or smear in service. Number 18. Pick test, also called the IGT test. It is a small printing unit which allows one to print a small strip of paper under controlled conditions. A specified amount of specific oil is added to the printing system and printed on the test piece. The surface is then examined for signs of disruption, otherwise known as pick in the trade. Results are correlated from a time calibration table. It is essential that the paper surface does not pick when printed, as pick means that some of the deposited ink may be lost from the surface, and in extreme cases the paper surface may start dusting. This means that the size and binding agents are not working and the fines of the fillers and opacifiers are loose on the paper surface. Number 19 is the pH, chloride or sulfate. These factors are tested on an aqueous extract of the test piece. The acidity or alkalinity pH can help the life of the paper or board, as the natural pulp is slightly acidic and goes dusty and powdery in 50 to 70 years. Most papers today are neutral. Sulfates should be more than 20 mg per kg of sample, and chloride can vary with the cleaning process of the pulp. The conductivity of the test piece can also be determined in the aqueous extract. Number 20. Roughness / smoothness. This is a measure of the extent to which a paper or board surface deviates from a plane and involves the depth, width and number of departures from that plane. This is very important for the printability of the paper. Number 21. Brightness. This is the reflectance factor measured at nanometer with a reflectometer. Number 22. Opacity. This is the ratio expressed as a percentage of the luminous reflectance factor of a single sheet of the paper with a black backing to the intrinsic luminous reflectance factor of a layer or pad of the same paper which is thick enough to be opaque. Number 23. Denison wax test. This is an older test that was largely replaced by the IGT test, but is still used by some older paper and board mills. It consists of a series of specialized waxes which are heated to a specified temperature, placed on the paper surface, left to cool, then removed. The wax formula picks dust and debris from the surface, and the wax formula number that shows the picking indicates the degree of ink viscosity or stickiness that the particular paper will tolerate without risk to the print. Number 24. Wet waste strength. This is used for determining the wet wasting strength of any paper or board following immersion in water. Number 25. Wet tensile strength. This is a method of determining the wet tense strength of any paper or board after immersion in water. 26. S in paper and board. This is a method of determining the S content, that is, the inorganic matter left after controlled combustion in paper and boards. The method is suitable for most loading materials and coating pigments. Number 27. Detection and estimation of nitrogenous agents in paper. This standard describes the problem involved with the nitrogenous treating agents for paper and giving qualitative and quantitative methods for use with certain agents used in paper treatment. It applies only to substances that have a strong affinity for acid dyes. Number 28. Ink absorbency. This gives recommendations for the determination of the ink absorbency of paper and board by K&N ink. Applies to both paper and boards to be printed by the lithograver or letterpress process. Hope the students would have been well understood the various testing methods and specific requirements for paper and paper boards. Now, we will move towards a brief discussion on folding cartoons. Module 4, Folding Cartoons. Folding or collapsible cartoons. These difficult to handle temperamental objects in white lined folding boxboards are popular in the industry because they are good at their job, which is to contain, protect, and distinguish the product from all others in an economical manner. They are sometimes known as secondary packaging. Ethical products should either have a print-free area or a printed area which does not contain vital or legally required information, which would be covered or obliterated when the pharmacist label giving information for the patient is applied. The standard size for this label is 70 mm by 40 mm or 70 mm by 35 mm. Choice of design. When choosing a cartoon design, the following points should be noted and fully discussed with a printer used to dealing with pharmaceutical products and with the necessary levels of hygiene, control, quality control, and inspection. Number 1. Style. This could be from a catalog of cartoon designs. This includes the method of flap retention in its style parameters, that is, lock slit, friction fit, claw lock, crash lock, envelope lock. Number 2. Type of boards. Each of the type of boards mentioned comes in various calipers ranging from about 200 meter up to around 700 meter. This will depend to a large extent on what is going to be put into the carton. Allied with the size. Board surface facing materials need to be decided as these will affect the type of printing chosen and may affect the creasing and subsequent cartoon erection. Number 3. Layout. It is usual to have the top opening flap opening away from the opener with the glue flap around the back of the carton placed so that it interferes as little as possible with the overprinting operation. Number 4. Size. This has been mentioned above. Only make the cartoon big enough to contain the contents and allow enough clearance for machine operation. Number 5. Graphics. Understand what graphics are needed and the limitation of each of the printing process you are likely to use. One color is easier and cheaper to print than 4 color process. Number 6. Quantity to be produced. If only running a few hundred cartoons of one particular type, then choose the process with the cheapest plates and shortest make ready. That will be the cheapest, that is, one color flexographic or letterpress printing. At the other end of the scale, if you wish to produce 4 color process printing with screens and tones and produce them by the tens of millions, then either offset, litho or gravure printing is the choice. Number 7. Method of printing. Usually using offset, litho, flexography, letterpress or gravure may include hot dye, stamping, foil blocking, embossing, debossing. Specific test for cartoons. Number 1. Compression. 3 methods can be used to assess the strength of the erected package, thereby estimating the degree of protection that it confers on the contents. This is particularly useful for products with no inherent strength in one plane or another, that is strip packs. Number 2. Cartoon opening force. The method that is often used is to hold the flat cartoon as delivered by its creases between thumb and the first finger and press. The cartoon should spring open into the square position without a need for unreasonable force. If the cartoon does not spring open or buckles in on itself, then it is reasonable to assume that those particular cartoons will cause problem on any cartooning machine. This can be measured by instrumentation. Number 3. Coefficient of friction. Both the static and kinetic coefficient of friction are determined by sliding the specimen over itself under specific test conditions. Number 4. Crease stiffness. It is also called the crease recovery test. This involves testing a carton board piece and folding it through 90 degrees. It will then try to recover its former position when the bending force is removed. Number 5 is joint shear strength. This is a method of testing the glued lap seam on the slide of a carton for strength of the adhesive using a tensile testing machine. This quantity is important in ensuring that the correct adhesive for the cartoon board finish has been used and in the right quantity. Module 5. Conclusion. With all these information, here we come to end of today's lecture. Hope we have understood the basic applications of paper and paperboards and cartoons in pharmaceutical packaging with an eye on their quality control. Further, have a look again on the complete topic yourself so that you are thorough with it. The topic that we have discussed today is very simple. So dear student, this is Dr. Rishi Paliwal, leave from you with the hope that you enjoyed and understood today's lecture. We will continue in our next lecture with the topic metal containers. If you want to learn more and enhance your knowledge, you may log on to our website for multiple choice questions, quizzes, LORs, www.cec.nic.in. Till then, keep studying. Goodbye.